All right, hello everyone. We're just gonna get back to our session 2 basic network topology that we have been analyzing lately, and we're just reviewing some of the aspects of a basic network topology. As we can see here, we got two end devices. One more time, we have a PC and a laptop, and we also have a switch. Okay, and just a refresh, a switch is a layer. Guys, switch is a layer what?
Layer 2.
Is a layer 2 device. Perfect. It understands MAC addresses. Okay? And basically makes decisions based on the MAC address. Yes? So based on the MAC address, a switch is going to look up into its MAC address table in order to determine which interface it needs to send. It needs to send a frame to. Yeah? It needs to send data to. Is that all good? Is that all clear? Okay, we were talking about this, but there's actually a way in Packet Tracer that you can find out a MAC address of a certain device. If you click into the device itself and you open up a command prompt, if you type the command ipconfig/o, you're gonna list all the IP configuration into a certain device. And as we can see here, we have the physical address, which is just basically the MAC address for this device. Yes? That all clear? Here, as you can see, we haven't set it up an IP address, so we're not able to establish communication between these two devices, because in order to establish communication between them, we need to make sure we set up all the addresses needed for the OSI layer model in order to establish a communication. Is that all clear? So right now we just basically going to assign IP addresses to these devices. So I'm just going to grab the first PC, PC0, and I'm going to assign an IP address for this device. Yeah? So if I just start typing 192.168, which address you guys want to set? I'm just going to set 1. Okay? So 192.168.1. This device is going to be a little bit special. It's going to be 129. Okay? And if you remember, I gave you the exercises, but at this time, if you have done the exercises, you will know that these address, it belongs to a specific class of addresses. Does anyone remember which class of address this address belongs to?
Class C.
It's a class C address. If you check out the page, the first page of the exercises I gave to you guys, in the tables I gave to you, you actually have this info there. Okay? So there's a standard subnet mask for this address because it's a class C address. Does anyone remember which subnet mask is a standard subnet mask for this type of address?
255.255.255.0.
Yes, perfect. Or in other words,
24.
it's just a /24 subnet mask. Yes? Is that all clear? Perfect. So basically, if I just press tab, it's going to auto-complete the subnet mask according to the standard subnet mask for that specific type of address. Is that all good so far? Now pay attention to something. If I just want to keep communication within a LAN, I have no need to worry about the default gateway. I'm just going to leave it at 000, whatever. I don't have to configure it. So I'm just going to leave it. I don't need to mess up with it. Yes? Is that all clear?
Yes.
Perfect. I'm just going to do the exact same thing on the laptop and we see what happens. I'm just going to click ipconfig. I'm just going to set up an IP address for this. 192.168.1. This one's going to be special. The other one was 129 this time. This one's going to be 130. All right. Now the subnet mask. I press tab. It's going to autocomplete. Is that all good? Perfect. Now I'm ready. Okay, I'm ready to establish communication between PC0 and laptop. So I can just come to either one of them Just gonna choose the PC0. I can open up a command prompt. Okay, and we already talked about these. There are two main commands that are extremely important for us to test end-to-end connectivity. Does anyone remember which commands are that? Are these?
Ping and trace route.
Ping and trace route. You actually have a question in the exercises that I gave to you that basically asks what two commands you can use to, troubleshoot or test end-to-end connectivity. Just gonna basically execute the command ping 192.168. Before we do this, I already talked about this. Let's see if you guys remember. What happens if I try to do this ping to 127.0.0.1? Does anyone remember what this is?
Loopback address.
This is also known as the loopback address. It's just basically testing connectivity to itself.
Yes.
Okay? So I'll just basically do it, and as you guys can see, it just gets a reply back. So it's just basically testing all the OSI layers into this device specifically. Yeah? All good?
This is pretty cool, Dad. Check this out.
Perfect. Now let's do 192.168.1, and then let's type the old address, the laptop
Yeah.
address. It's
So
130.
I've created two IP addresses, one for the PC and one for the. God damn it! I'm on mute.
Jonathan? I didn't get what you said.
Sorry, mate. I just didn't realize my mic was always talking to my old man.
No, it's all good. All right, so let's do this. Let's see what happens. Yeah, so it's working. There's connectivity between PC0 and the laptop. Okay, now let's just do something here. Let's try to change the subnet mask and see what happens. So I'm just going to come here to the PC0 IP address interface, and I'm just going to change it. Okay, I'm going to change this IPv4 address from 129. Now, actually, I'm going to keep the IPv4 address. I'm just going to change the subnet mask. How does that sound? Let's break stuff. All right. So I'm just going to change from /24. I'm going to change to /25. Okay. So I'm just borrowing. If you remember what we said last week, we are borrowing one extra bit to define a subnet. Yes? So instead of using the standard /24, we're just gonna use /25 address instead of /24. So the standard subnet mask is 255.255.255.0.
Yeah.
Let's get to /25. So what would be the value here instead of 0 if it's /25, guys?
Is it going to be 8?
8?
9.
8? Guys, I want /25. This
It's
is already
25.
/24.
We need one.
I want to change to /25. Does anyone know? Yes, Jessica, perfect. So it's going to be 128. So if you're wondering why is 128, remember these first three, they're each one representing 8 bits set to 1. So when you set all 8 bits to 1, you get 255. So what you have is 255, 255, another 255, so you're up to /24. You want to borrow 1 bit more, but this 1 bit that you're borrowing is the very first bit to the left of an IP address octet, and that is equivalent to 128. Is that clear?
Sorry, even
Yes.
if on the, sorry to disturb, if I put the 8, with the 8 is also coming 1 though.
No, if you put 8 here, it's not going to be valid for subnet mask.
But when I'm doing the binary with the 8, it's 1000. So on the left there is 1.
1000.
That's what my calculator is saying. Let's see. 8. Yes, the binary is 1000 of 8.
Yeah, but you remember you need 8 bits for an IPv4 octet.
Oh yes, sorry.
So you
Sorry,
would need to put zeros to the left, but if you put
Oh,
zeros to the left, it's not a subnet mask anymore. A subnet mask needs to have all ones to the left.
sorry.
So 8 is not a valid subnet mask.
Yeah.
Is
Sorry.
that clear?
Yes.
Okay. So I'm just gonna change it to 128 now, and let's see what happens. Just gonna close it. Command prompt again. Right. Try to do it again. It's working. Now, does anyone know why it's working? Try it again, and it's still working. Any ideas?
They're still in the same LAN?
Yes, even though I changed the subnet mask on one side, if you actually calculate the network address, it's still going to be the same. Now look at this. I'm just going to change this address slightly. Instead of having it set to 129, I'm going to change now to, let's say, 1. See what happens. I'm going to ping itself. It's working. I'm going to try to ping 1. Is that 130? Yeah. Doesn't work anymore. Yeah? And that is because now they are not in the same network anymore. Yes?
Mm.
Let me just open a notepad and let's just discuss about this. What I just did. Okay? So we had this 192.168. Okay? 1. And we have 129 before. Okay? And we set the subnet mask to /25. Okay? This is what we did. So we had this before. So what I need to do first is calculate the network address. Yes?
Yes.
So how do I calculate the network address here? Anyone remember how to do that?
With the subnet mask address?
With the subnet mask and ending. Thanks, Sabiha. So I'm just going to convert these values to binary. Okay? So if you have the exercises with you, please open the page where I gave you the table and let's do it together. It should be easy. So 192 is going to be the first bits to the left and everything else set to 0. Yeah?
Yes.
1, 2, 3, 4. And then you got 168. 168 is 128 plus 40. So this is 128. Do I need 32?
No, you don't need 64 or
I
32.
don't need 64, but I need 32.
42. Yep.
So up to here, I'm already 128 plus 32 is 160. So I already have 160. I don't need 16, but I need the 8. And I can put everything else to 0. Is that clear to everyone? Is that too fast?
No.
If it's too fast, you can just grab the table that I gave to you guys from the exercises and just have a look and you understand exactly what I'm doing here. So number 1 is just the easy one. You just need 7 bits to the left and 1 bit to the right. Okay. And then you got 129, which is just basically 128 plus 1. So the first is set to 1. Then you got 6 bits to 0. And the last one set to 1. And then you got /25 subnet mask. The subnet mask just basically tells you all the bits to the left that are set to 1. 1, 2, 3, 4, 5. Oops. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. So up to here you got 24. You got one more, 25. 1, 2, 3, 4, 5, 6, 7. Yeah? Now let's do this. Should be easy. What else?
So it's one and all zeros.
1
Just one.
for the network. Do the ending. You only have 1 where you have 2 ones. So you have 2 ones here.
Just
So this is actually 128. Everything else is set to 0, yeah? And this is /25. So this is the network address. What's the broadcast address? Anyone remember? You set all these
You
zeros to
chose
1
this one.
after you calculate it. So 192.168.1.
255.
5.
Yeah? Everything in between, and that is 192.168.1.129 up to 192.168.1.255 is a valid host in this network. Yes?
Yes.
Perfect.
Why have you got 255?
No, 254.
254. Yes.
254.
Yes. Now it's perfect. Yeah? Thanks,
Yes.
guys.
Yeah.
It's all good? Now you understand exactly why is the /25 will have these
Yes.
addresses. So basically every host that you have in the network that is between this and this, you are able to ping within this subnet mask. Okay? But we just basically, after that, we just basically changed it. We changed it to 1 and then we broke stuff. Okay? Remember, the other computer is set to 1.130. Okay? So when we kept the 129, we were still able to ping it because it's still a valid host in this network. Okay? But what happens is after we changed it to 0, we weren't able to communicate anymore. And why is that? Let's do the calculation. So after we changed it to 1, we then broke everything and then they were not able to communicate anymore. And why is that? Because we need to calculate the valid hosts between this in order to find out if they can still communicate or not. So I just basically need to do exactly the same I did before. So we did this one and then we did this one. Okay, so let's do the second one, see what happens. So you need to do exactly the same ending, but now it's not 129 anymore, it's 1. So I'm just gonna copy and paste just because I'm lazy. Okay, but now it's slightly different. It's not 129. This one is not 129. It's 1. So it's just a 0 here. Everything else up to here is a 1. Is that clear?
Yes, thank you.
Okay. 192.168.1.
0.
Remember, this is now a /25. Okay.
Yep.
What else do? You need to calculate the broadcast. What's the broadcast? So after
255.
calculating the network, you need to set all the original bits in the subnet to 1. If
Yes.
you do that, you just need to change 7 bits to 1. But the first one is 0. So what's the value that you get for the broadcast?
255.
255.
No, it's not 255. Is 127, guys. Remember, this one is still
Yes, yes.
this one cannot be changed because the subnet mask is telling you up to here
0.
cannot be changed. This belongs to the network. In this
Yes.
case, the subnet. This bit has been borrowed. Remember, it has been borrowed. So if you set everything else to 1 except this, you get
127.
127.
Yep. Get it. Clear.
Now, can you tell me what are the valid hosts in here?
192.168.1.2. 1. Sorry. 1,
1.
2, 192.168.1.126.
Exactly.
Correct.
So that now you know exactly why we broke stuff. Because when I changed the address to .1, I actually changed the network as well. And now these two computers, they are not in the same network anymore. And how do I fix that? By changing the address. I want to change the laptop to make this work. So I need a value for the laptop that is in between the range that I just calculated according to the desktop. Okay? So any value between 1 and 126 is a valid address for me to put it in there and establish connectivity one more time.
Yep.
Yeah? So which address you guys want to go for? .1?
124 or 120.
124.
Yeah. Remember, 1 is already being used. If you set up
Yep.
another one as 1, you're going to break stuff. They need to be unique in the same LAN. All right. So I'm going to grab 124 as you guys said. And remember, subnet mask is now 25.
120.
Yeah? I'll close this. And now let's try connectivity one more time, see what happens. Is that 1 dot? Is it working?
Yes,
How can you tell?
because it's got a reply.
It's got replies. Okay. I can also try another command to troubleshoot. What's the command?
Trace route.
Trace route.
All good? Any questions so far? Now let's use Packet Tracer to review something really important. Okay. Let's say you want to connect this to the internet. All right. You want to connect these network topology to the internet. Perfect. So you basically need a router because the internet is a different network than this. Okay. As you guys see, this is a LAN. So all the addresses you use inside a LAN, they are called private or public?
Private.
Private. So all the addresses inside of the LAN, you use private addresses. Let's do this review here. Okay, so all the addresses within the LAN, they are called the private addresses. Okay, specifically for this case, we're using class
C.
C in this case. That's what we're using. And remember, we are using 192.168. What else?
.1.
What's the network address?
194.
The network address that we just calculated, guys, according to the subnet. What is it? 192.168.0. Here it is. This is the network address. Yes? And this is called what?
The broadcast.
And this?
Host.
Yeah? So let's do something fun then. You gonna grab a computer? Do you guys want to grab a laptop, a server? What do you want? I'm gonna grab a server. Put it here. Okay? So I want to make sure this server is able to communicate with all these computers. Okay? This is going to be a file server. So it stores files. All right? So I want to make sure this server can communicate with the laptop and the PC. I need to make sure my PC and my laptop can back up files to this file server. How does that sound? Cool. Okay, let's do this. I'm gonna grab a copper cable one more time from the server, fast Ethernet 0 to the switch. For this one, I'm going to use a gigabit Ethernet because usually you're gonna require more bandwidth for the server because sometimes you have to communicate at the same time to the server, so you need more bits to be transmitted at a certain time. Just gonna use a gigabit interface. Yeah, as you guys can see here, it's still orange. It takes some time to start working. Just give it a little bit more time. All right, so I need to choose an address for this server. I need to choose an address for this server so that this server is able to communicate with the PC and the laptop. Can you guys help me choose that based on my calculations?
192.168.1.119.
The 119? You want 19?
Yeah, 119.
Okay. So I'll go to my server configuration. I can do it here on the fast Ethernet. Set up the IP address here straight away. You have an option to set it as DHCP. Does anyone remember DHCP stands for?
Dynamic Host Configuration Protocol.
Dynamic Host Configuration Protocol. So we would gather the IP address from a server, from a DHCP server. We don't have a DHCP server in this scenario, so we just need to set it up as static. So this is one way of doing it. The other way of doing it is you go to the desktop itself, IP config, and then you set up the IPv4 address here. Let's do it here. What's the address?
1.1.119.
All right. So if I hit tab, it's going to autocomplete. But I'm using /25, so I'm just going to change it. This is 128. Okay. I need to make it consistent across the network. Now I just close it. So let's test connectivity from the server to the PC and laptop. How would I do that?
Ping it.
Yeah, command prompt. What's the address? It's
1.119.
No, this is the file server itself.
Yeah, 119.
Yeah, but
No,
I
you
want to
need to
test to
pick
the
the
PC and laptop.
PC or the laptop.
It's, I think we set it up.
124.
124 is the laptop. Let's see. It's all good. What else? How about the
130?
PC?
Oh, sorry.
I think it was 1, isn't it? Yeah. Now, guys, look at this. What happens if I try to ping the broadcast address? What do you guys reckon is going to happen?
It'll fail. Timeout.
Look at how interesting is this. .1 address is which address?
PC.
The PC. And .24 is which address?
The laptop.
The laptop. Now you know exactly why this is called the broadcast address, because it's the address used to reach everybody in the same network. And that is why you cannot use the broadcast address for anyone else, because it's reserved to communicate with all the hosts within that specific local area network or that specific network. Is that all clear to everyone? Really interesting, isn't it?
Yep.
Awesome. Now there's another way that you can actually see this. So if you click here into Packet Tracer, you have a real-time simulation. So it just does the simulation in real time, or you can choose the simulation mode. So the simulation mode is just going to basically do everything in slow motion, and you can choose the steps that you want to go through. So I'm just going to do it, and let's see what happens. As you can see, it does nothing, okay? But I can just do exactly the same thing, okay? I'm just going to do the ping. As you guys can see, I did the ping command. You see that there's some sort of a letter here on the server, and then it doesn't do anything else. That is because it's waiting for me to skip the steps. So it's waiting for me to move forward. So it's just basically everything it's in slow motion. So I just need to do step by step. If I come here and I do play controls, I can just do next. And as you guys can see here, something's being sent, a letter is being sent, and we already talked about this. This letter's got the data inside of it. It's encapsulated. Yes? As you guys can hear, there's a specific protocol being used as well, which is ICMP. So that's the name of the protocol being used. All right? So if I keep doing it, check what happens. Yeah? So basically this envelope that was sent to switch was then just basically duplicated and sent everywhere else. And then I can move next. And then each one of the devices reply back. And then it is sent back to the server. The other one is also sent back to the server. The other one is also sent back to the server. And then to everybody. Yeah? So it's just basically another way of doing it in simulation mode. Awesome. Now let's discuss a little bit more about the default gateway, because I got a question about the default gateway. I don't think it's clear for you guys. So far we have no idea how to calculate a default gateway address. What is this called, default gateway address? You remember the role of the default gateway is to be a door to the outside world, or to be a gate to the outside of the network. And remember, a device that allows connectivity between different networks is which device?
Router.
A router. So I can just come here, grab a router, and I'll show you how it looks like. Just gonna grab any router. Could be 2011. It could be anything. 1941. Okay. So I'm gonna put my router here. And just because I know this router allows connectivity to different networks, I'm gonna put it here, just in the limit of my network. How does that look like, guys? Look good?
Mhm.
Awesome. So this router will allow me to connect to another network. Yeah? So basically what I'm going to do is I need to connect this router to this switch. Okay? And the way of doing this is exactly the same way we did everything else. Just gonna grab a cable, and that the connectivity between a router and a switch is just a straight through copper cable. So one more time, because this is going to require more bandwidth, because everything that goes out of the network needs to go through this interface, I'm just gonna choose a gigabit interface. Done. Is that all good? Now I got my router connected to my switch. And then this router could be connected to the internet, it could be connected to the ISP, internet service provider, and then it would allow me to connect to other networks. This router is which layer, guys, in the OSI model?
Layer 3.
It's a layer 3 device. Okay? So a layer 3 device, and this device makes decisions based on the
Gateway address.
based on the IP address, the logical address. So the router will make decisions based on the IP address. So the router has something called the routing table, which is just basically a table with IP addresses and destination interfaces. Is that all good? So it's just going to make decisions based on the routing table. So now you don't have to worry about this, how to configure this router, because as you guys can see here, this link is red, and that is because you need to enable the interface on the router manually. It's not as a switch. A switch is going to configure its interfaces automatically, but the router will not do that. You have to do it manually. But you don't have to worry about this for now. This is for more advanced courses. For network essentials, you don't need to know how to configure this router. But you need to know that this interface of the router that is connected to our LAN needs to have an IP address in the same LAN. And that is because this interface of the router is connected to our switch. Okay, so this interface of the router needs to have an IP address that also belongs to our network. Yes? And this is what we call the default gateway. It's the interface of the router that is facing a certain network. This is the default gateway. So this default gateway, which is the interface of the router facing our local area network, okay, needs to have an address in this range. Could be anything. What is usually done is the last address that can be assigned to a valid host is usually, it's not always, it's usually what the network engineer or the network designer chooses to be the default gateway address. It's usually, but it doesn't have to be. It just have to be one address in the valid host range,
Why is it?
because it needs to have connectivity to all the devices within the LAN. So it needs to be an address in the same network. If this is a different address that is not inside this network, this interface of the router cannot communicate with anyone in the LAN. That is why. Does that make sense now?
Yep.
Perfect. So what do you guys suggest that I should give this interface of the
Yes, thank
default
you.
gateway? What address do you guys want to give this router?
192.168.1.126.
Yes, it's a nice thing to choose the last address to be assigned to the default gateway, and that's because it's easy to remember. And because it's easy to remember, you can go to each one of them, each one of the endpoints, and configure it. So I can just come to my PC, IP configuration, and now the default gateway address I need to put in here. Which address is this?
192.168.1.126.
Yes, perfect. Now you guys know where the default gateway address is taken from. I think we have a special attendance tonight. It's a very special student, Daniel Gutierrez. Who's Daniel Gutierrez?
Oh no, not Daniel.
Hello, guys.
Welcome.
Daniel.
I'm so
Welcome,
bored
Daniel
in my
Gutierrez.
class. No one's there, so I came here. I just need to hear people talking.
Daniel, did you get stood up?
Yeah.
Welcome, Daniel
Oh,
Gutierrez.
no way.
Thank you, guys.
I'll tell you something that if you're not enrolled into the class, you have to pay a fee to attend my sessions. So it's currently
Yeah.
$200 an hour.
$200. I was thinking of a coffee on Friday.
So yeah, that also works. That
That
also
also
works.
work.
All right, guys, is this clear? How you find out the default gateway address? How do you configure it and everything else? That all good? I hope this is clear. And remember,
Yes, thank you.
guys, this could be connected to another network, entirely different network. And the router will make the decisions to forward traffic within the same lane or send it somewhere else, and so on and so forth. That all good? There you
Yes,
go.
thank you.
You guys know exactly what happens now. Now I'm gonna do something. You don't have to worry about it because you're not required to know this. But I'm gonna configure this router interface just to show you guys what happens. I'm just gonna go to the IP addressing. It's gigabit 00. So it's just gonna be 168.1.126. And the subnet mask is 128.
128.
I don't know if you guys realize, but whatever it is that I type in here, it shows some commands here, and that is because the router can be configured using commands. But you don't have to worry about this. This is for more advanced courses. So if you do the Cert 4 Internetworks, you're probably going to start doing this. For Network Essentials, don't worry about it. All right, after I do this, I'm just going to close it. I need to enable the port because as you guys can see, the port is in off state. So I need to click here on this on button, and then it changes the interface to up state. It means the interface is now on. Okay, so now just close this, give a little bit more time. I can also fast forward time, and done. Everything is green now. Yeah, looks like a Christmas tree. Awesome. So what we're gonna do now is let's get to our file server. Okay, and let's execute a ping command to my router interface, to the default gateway. It's working now. Okay, everything is ready. Everything is working. Beautiful. Now, what do you guys reckon is going to happen if I try to ping the broadcast address?
It should work.
It should work, and I should get a reply back from everybody, yes?
Yes. And you did.
Who is 126?
That's the gateway.
The default gateway. Who's 1?
That's the PC.
And who's 124?
The laptop.
The laptop. Everything is working beautifully. All good? Now let's check it out. What happens if I do from the PC1 to the broadcast address? What happens? I'll get a reply back. Oh, I did a trace route. I get three replies back. One from 124, which is just basically the laptop. One from 119. And who's 119?
Oh yeah, that's a file server.
That's the file server. Yeah? And who is 126? The default gateway. And now it's where you need to pay attention, guys. Who is the device responsible for allowing connectivity to other networks?
The router?
The router. We already said that. And the router is a layer
3.
3 device. Perfect. Okay? So basically the router makes decisions to forward traffic to different networks, and that includes the internet, to the ISP, and so on and so forth. So basically, what do you do when you're trying to troubleshoot connectivity to the internet? Is you check if you have connectivity to the default gateway. You check if the default gateway is a valid address, and you ping the default gateway to test connectivity. This is the first troubleshooting step when you're trying to troubleshoot connectivity to the internet. All good? Thumbs up?
Yes, thank you.
All right. There you go, guys. It's a little bit more advanced for you. I strongly suggest you to go through this by yourselves. All
So,
good?
yep, Robert. Sorry, can I ask a question? Just this is sort of getting a little bit off track, but with the project, do we, because we're going to have staff with laptops and stuff like that, do we need to know how will they connect to a router, like to the LAN through the switch to the router through when they come into the office to with cables, or will it be Wi-Fi?
It is up to you.
Oh.
But remember, you have a budget. So you just need to do some research to find out the price of each one of the devices that you're suggesting. So if you're suggesting to have a switch with wireless capabilities, you need to be aware that you have cost involved. Okay? So you just basically need to make sure you're doing the right decisions based on what budget you have.
Right.
But you can basically choose whatever you want. So like if you say I want to go wireless and it's still within the budget, it's up to you. Oh no, I want to do wired devices because Ethernet cables are not that expensive, and I think it's the best choice for this because it has lower interference and so on and so forth. You can just basically justify yourself. Justify the decisions, and it should be all good. Yep.
Okay.
Perfect. Let's get to the lecture, guys. And I promise it's gonna be quick. Really quick.
Have you still got your microphone on?
Yes. I think so. Yeah. Just kidding. All right. Providing network services. I don't know why my test bar is showing up here. Just give me 1 second. I'm gonna hide it. Yeah, much better. Awesome. Today we're gonna talk about providing network services. We're gonna talk about how clients and service work together. We already talked about this with the packet tracer file, so you don't have to worry too much. We're gonna talk about how internet protocols work and how application protocols and services work. All right, the client-server relationship. So this is just basically an example of what happens when you want to retrieve some type of information from a certain server. Okay, this server is located anywhere in the internet. Okay, it is located into a premise of some vendor or some provider or whatever. Okay, could be an ISP, could be anything. Okay, what you need to know is that there are millions of servers, okay, out there in the internet. There are millions of Microsoft servers, millions of Google servers, millions of Facebook servers, millions of Instagram servers all around the globe. All right, and when you have everything connected, you have this beautiful thing called the internet. Each one of these servers, they are providing a specific type of service to a specific type of organization. It could be email for Microsoft. So if you have a Microsoft email account, there should be a server out there that is responsible for dealing with Microsoft email accounts and so on and so forth. For financial transactions, if you have a Commonwealth Bank, there's a server, a Commonwealth server located somewhere out there that's got all your account information, that stores all your account information, that stores all your account transactions, and so on and so forth. The primary characteristic of a client-server system is that the client sends a request to the server and the server responds by carrying out a function. It could be a document, okay? So if you have, for example, see you, Daniel, thanks for coming, mate. For example, you have your Commonwealth Bank account and you want to check the transactions. What do? You just basically grab an endpoint device that could be a desktop, a laptop, a smartphone, a tablet, whatever, smartwatch, even a smart fridge. If the smart fridge got web browser capabilities, you're gonna have access to your Commonwealth Bank account, and then you just basically making a request to a Commonwealth Bank server that's got all of this information. And then this server is just gonna basically send the info back to the client. This is the client server architecture that everybody talks about. Usually when you want to retrieve a certain type of information from a server, you usually do it using a URL. A URL is just basically a uniform resource locator. It's just basically a way of retrieving information from a server. Okay? So basically this URL is made of components. The first component is the protocol being used, as you guys can see here. It could be HTTP, and it could be a more secured version of HTTP. Does anyone know what a more secure version of HTTP is?
It, HTTPS.
HTTPS. That's good. And that's basically because HTTPS uses encryption. All right? So your data is not traveling out there across millions of other networks as plain data that is visible to everywhere, to everybody. It's just encrypted. Okay? That means if someone intercepts the information before it reaches the server, the person ideally and theoretically is not going to be able to read whatever it is in there because it's going to look like scrambled eggs because of encryption. All good? And then you have the domain name, which is just basically where the information is. All right? And then you have location of the resource on the server. The second portion is where the resource is located within that specific server. And then the last part is the resource itself. Some protocols used for internet services nowadays, we have the well-known domain name system, also known as DNS. It just resolves the internet name to IP addresses. So basically, every time you want to find something out, you reach out to Google. Most of the time. Some other people have poor life choices and they use Bing or some other stuff. It's up to you, I don't care. But basically, you want to reach out to Google because you want to find out something, right? You do not know Google's IP address. But even not knowing Google's IP address, you are able to make a request to the server. And that is because of this beautiful protocol called Domain Name System, or DNS. DNS is just basically going to translate a known name, a name that you can read, to an IP address. So when you type into your browser www.google.com, you don't know the IP address, but you can reach Google server because DNS is going to kick in and it's going to find out the IP address for you. How easy is that? Basically, there is a command for you to find out an IP address based on a URL or based on something else. And that is the NS lookup command. So I'm just going to open my command prompt in my local machine and I'll show you guys how it looks like. Okay. Basically, the NS lookup command will just execute a DNS query using the name that you provide. So I'm just going to provide google.com and see what happens. I get a reply back. Who is replying this message? A server. And this server is called a DNS server. So easy, teacher. Yes, it is easy. And check this out. It's resolving google.com to this IP address or this IPv6 address. So I got two IP addresses for this. One IPv6, one IPv4. Can use whatever I wish. Okay. So you're telling me that now that I know Google's IP address, I can maybe try to ping google.com? Yes, I'm telling you this. Let's try and see what happens. It works beautifully. So I have connectivity to Google server, the one that is hosting google.com. Is that all good? Too easy? Too simple? Now let's
Yes,
use a
yes,
special
thank you.
let's use a special command that we learned, the trace route, because so far all the trace route outputs that we've seen, they are boring. So let's do a trace route to google.com. So I'm gonna type Google's IP address that we found out using DNS and see what happens. It's gonna take some time. Yeah, while it takes time, let's keep going. All right, so this is the DNS. You have another protocol called the secure shell, which is just basically used to provide remote access to servers and networking devices. So SSH is used when you need to configure a network device or a server or everything, and you are not there on the spot. So you use the internet connectivity, you use the network connectivity to configure the device even though you're not there. So it's a remote tool to configure a certain device. You have SMTP, which is just basically a mail transfer protocol. POP is also another mail transfer protocol, and IMAP is also another mail transfer protocol. But you might be asking, teacher, why do I need to know all these three? Why? Because they're different, okay? Each one is for a certain purpose. SMTP is to send the email message and to send the attachments from the client to the server. All right? So the direction of where the email is traveling is important here. When you're sending from the client to the server or between servers, we use SMTP. POP is used by the client to retrieve the email from a remote server. And IMAP is also used to retrieve email and attachments from the remote server. There is a difference between POP and IMAP. POP was used back in the days, and POP's got a disadvantage compared to IMAP, and that is POP will retrieve the email, and the email will not be kept in the server. So POP will just grab everything from the server, and it's gonna push it. It's not gonna leave there. It's gonna pull it. It's not gonna. Yeah, you guys got it. And IMAP is just gonna grab a copy of whatever is in the email server. We also have the DHCP protocol. We already talked about this. It's an automatic protocol to assign IP addresses, also known as the dynamic host configuration protocol. Web server, transfer the file that make up a web page of the World Wide Web using hypertext protocol, HTTP. So web servers, they usually use the protocol HTTP or HTTPS. We also have a protocol called the FTP, which is used to interact file transfers between you and a certain server, to transfer huge files between the client and the server. All right, let's check our trace route. All right, it's finished. Trace complete. How many entries we have here?
18.
18. And what does this mean, teacher? Basically, this is hops. Each one of these numbers represent a hop. And what is a hop? It's just basically every time you jump from a certain network to a different network. So every time you jump a router, you consider a hop. So these are all the routers, all the hop counts from the source to the destination. Is that all clear? Yeah? Perfect. Internet protocols at work. Various protocols are necessary to deliver web page function. at the 4 different levels of the TCP/IP model. So the TCP/IP model is just basically based on the OSI model. As you guys remember, we talked about this already. The OSI model is general, and the TCP/IP basically has some specifications on some of the layers. Okay, so the transport mode is TCP or UDP. The IP is the preferred network protocol, network layer protocol used. All right, that's all we have here.
Rob, can I ask you something?
Yes.
I have read somewhere like TCP/IP does have the protocols, but not the procedures, and the OSI is the detail thing, like how to do or the transfer data. So, is that the main reason we still need the OSI model?
No, it's just that the OSI model is more general. You're not specifying anything. It's more general. It's a reference model. That's why it's called the reference model, because it's just a reference. And this reference model will dictate the rules. But when you set up each one of the rules specifically, you're actually choosing whatever it is. And the TCP/IP model specifies some things from the OSI layers. So for example, in the OSI layer, you have the application, the presentation, session, right?
Right.
So the TCP/IP model just basically calls these 3 layers one layer. Okay, so it doesn't care about the difference between the 3 of them. It's just gonna say, it's closer to the user, so we're just gonna say it's the application layer. That's all. And the transport layer in the OSI model can be many things, but in the TCP/IP, it's just gonna say it can be only TCP or UDP.
Okay, I understand. That's a very specific one.
Yeah, so the OSI model is a reference model. It's just a
Okay.
reference. And the TCP/IP protocol is more specific.
So I was confused because whenever a new version or new thing comes up, the older one gets like not used very much. So it's not like that.
No.
Okay, I understand. Thank you.
Thank you. All right, let's move on. Keeping track of the conversation. A port is a numeric identifier within each segment that is used to keep track of the specific conversation between a client and the server. Ports are categorized in 3 groups: well-known, registered, and private. Every message that a host sends contains both a source and destination port. All right, we talked about IP addresses, we talked about MAC addresses, we talked about everything. We talked about layer 3, layer 2, but now there's a layer that we haven't talked too much about, which is the layer 4 of the OSI model. It's just basically the transport layer. Yes? And the transport layer, it could use UDP, TCP, whatever it is. Okay? What you need to keep in mind is there is data traveling between your device and multiple servers in the internet. Yes? So for example, I can be listening to a Spotify song into my computer, but at the same time, I could have my Netflix account opened and I could have a movie playing at the same time. How does my computer know which data is coming from the internet, what data belongs to the Netflix service, and what data belongs to the Spotify service that I'm running? So I'm running multiple services in my computer. How does my computer know what type of data that is coming from the internet belongs to a specific application? How?
The IP address?
No, the address is the same, isn't
It's
it?
a router.
The address is the same. So if the data is coming from the server, it could be a Netflix server to my computer. The destination is my computer's address. Yes? But how does my computer differentiate what is coming from the internet belongs to a web page, or it belongs to Netflix, or it belongs to Spotify? How does it know the application?
Is
It's
that
a
a
router.
protocol?
It uses the The port number.
Port number.
It uses the port number. This is the way that it keeps track of what belongs to each type of application. So as you guys can see here, this is an example. So POP3, we just talked about POP3. It's used for email communication, right? To retrieve an email from a server. Yes? So if I'm retrieving an email from a server, the server will send the email to me and the destination IP will be my IP address. Yes? My computer will know it's an email by the port number. So the port number used for POP is 110. And you may ask why, and that is because it's a standard. Okay? It's just a standard. They have chosen certain numbers, certain port numbers for certain types of applications. If you're browsing the web for a web page, it's going to use HTTP protocol, and HTTP protocol uses port number 80. Okay? If you're using an internet chat, and this internet chat uses IM as the protocol, the port number is 531. The port number is within the transport layer protocol. Is that clear? Does that make sense to you guys?
Yes, thank you.
Perfect. So this is how the computer differentiates what's coming from the internet, what type of data belongs to certain applications or to other types of applications. Awesome. Perfect. So the DNS are registered organized to the internet with specific level groups. Okay. So usually when you have a name for a domain, you have a .com, a .edu, a .net, and so on and so forth. This is what identifies a domain name usually. Okay. This DNS is hierarchical. Okay. And what does that mean? You have different levels. So you have a higher level and then lower levels for each one of the servers. So for example, you might have an address, which is, for example, ebay.com. Okay. The .com is a high level domain. But you can have a different one, ebay.com.au. Okay. In this case, it's a different domain. Okay. The high level domain is the .com, but you have an extra domain, which is the .au. So each one of the dots after the domain name, they are one of the levels of the DNS services. Okay, I need to mute someone. There's a lot of noise. Guys, can you mute your microphones, please, if you're not talking? Awesome. Okay, this is just an example of how it works. A DNS server contains a table that associates host name and the corresponding IP address. When you send a message to the server, the server will reply back with the IP address. And we just did an example for this. So we executed the command nslookup, and the DNS server contains the entries with the names to IP addresses resolutions. Okay? So if I just do nslookup, and we did google.com, but let's try to do cisco.com, see what happens. So we're with we get an answer back, and this answer back contains the IPv6 address and the IPv4 address for this domain name cisco.com. Is that all good? So I can just basically test it, 72.163.4.185. As you guys can see, I have connectivity. Now, one interesting thing, guys, that you need to note here is that the ping command also works with the IPv6 address. So if you want to go with the IPv6 address here, that should also work. doesn't like it. Oh yeah, I have some access. Let me see. Doesn't like it at all. Ping statistics 2, 4. Why don't you like this, huh? 1. Just gonna try it again. If it doesn't work, that means it might be blocked on Cisco end. I'm just gonna try again. Ooh. 2001 420 11011 185 2001 420 111. Yeah, so it might be blocked. All right, that's fine. But the normal ping works, so it's all good. Okay. All right. When a web client there's something else, guys. So we executed the command ns lookup, so we could resolve the domain name to an IP address. You need to keep in mind that you can do the opposite as well. So you can execute the command ns lookup. If you know the IP address and you want to find out the domain name, that is also something that you can do. So I can execute the same command, but instead of typing the domain name, I can type the IP address of the domain, and I should be able to receive the resolution for that. As you guys can see, this resolves to something cisco.com. Redirect ns cisco.com. All right. When a web client receives the IP address of a web server, the client browser uses the IP address and the port 80 to request the application. So port 80 is just basically telling it's a HTTP connection. All right. HTML is just basically a language that is used to design web pages. So this is the only thing you need to know. All right. FTP clients and servers. This is just an example of how FTP works. So usually FTP is used when you want to send a lot of data to a certain server. So for those of you guys that have designed a web page and had to host this web page somewhere in the internet, and you had to host the web page into a server, and you had to hire the server, and you had to push everything that you had for a web page to the server, that is usually done using FTP. So you want to send out all of the data you have to a certain server. So FTP provides an easy method to transfer files from one computer to another. So it doesn't have to be just a server, it could be another computer as well across the internet. Perfect. Now we get to the difference between Telnet and SSH. So I told you guys that SSH is used to manage devices remotely. Okay. Telnet has got the same purpose as SSH, but the difference is Telnet is unencrypted. Okay. So Telnet is not secure. All right. So the analogy is that when you compare HTTP to HTTPS, and we say that HTTPS is more secure because it uses encrypted traffic and so on and so forth, you have basically the exact same thing between the difference in Telnet and SSH. All right, so SSH provides secure remote login and other secure network services. It provides stronger authentication than Telnet and supports the transport of data using encryption. All right. A little bit more about emails and messaging systems. Email clients and servers. Each mail server receives and stores mails for users who have mailbox configured. Okay, so if you have an email account, there's an email server out there on the internet that stores all your emails. We already seen that the email protocols that exist are SMTP, POP3, and IMAP4. We also have instant messaging systems. They require minimal configuration to operate. And after the client is downloaded, is required to enter username and password. So an example of an instant messaging system would be a few years ago we had something called the MSN. I don't know if you guys remember that, but it was an instant messaging system. So you had to log in and you could just basically talk to someone else that would have the instant messaging system installed and properly configured as well. We also have internet phone calls. So every time we're talking about IP telephony, it's just basically telephones that are connected to the internet and they are able to communicate using VoIP, okay? Voice over IP. So it's just basically another way that people found out they could enable phone calls, and that was by using IP. So you can actually execute voice calls and these type of things using IP as well. And in order to do that, you need to have an IP capable phone. All right, finished. Finally. All right, guys, do you have any questions so far? All good? Perfect. Disco. Just kidding.